All right, before you get started looking at derivatives of exponential and logarithmic functions, it's probably a good idea to think back about some of the logarithm laws you already know from previous math courses. Now, I have two columns here on this page, one of which just has various logarithm laws written out in base 10 logarithms, right? Like that statement there means the same as x is 10 to the y, right? Exponential form, logarithmic form. Well, you can do the same thing with natural logarithms. It's just base e here, right? The way we got this, or one way to think about getting that, is doing the anti-log base 10 on both sides, because that cancels out. You can do the same thing here, anti-log base e. Those are inverses of each other. You have x is e to the y, right? Natural logarithm is base e. Log of 1 was 0. Log of 10 was 1. Same thing over here. Ln of 1 is 0. Ln of e, since that's the natural base there, is 1. Log of 10 to the x. These are inverse functions here. Log of something and 10 to the power of something. Log and anti-log just gives you an x. Well, same thing works here. If you take the natural logarithm of e to the power of something, you just have that number itself, x. Or in the reverse order as well. 10 to the power of log x is just x. E to the power of ln x is just x. Those things cancel each other out, those two functions. All right, now you also had some logarithm laws for various operations. Likely the first one you looked at was the pattern you found when you had the logarithm of a product. And with some investigating various numbers and stuff, you likely found that the log of a product was the sum of the logarithms. Hopefully you did, because that's what it is. In other words, example, right? Log of 6 is the same as log of 2 plus log of 3. Works the same way with natural logarithms. Natural log of that product is going to be ln a plus ln b, right? Because natural logarithm is just another logarithm. It's just like any other base, because any of these rules would work in any base, and this is no difference. Base e. You could actually write, that's the button on your calculator, but you could actually write it like this, log base e. Just like you could write log base 7 of something. You could write log base e of something. But for some reason, that's the shorthand that people use. Rest of the laws here, this was logarithm of a product. Well, you got logarithm of a quotient here as well. Logarithm of a quotient, you might have guessed that you subtract those logarithms. Same thing over here, ln a minus ln b. Test it out with any numbers you want, right? Quotient and then the two individual numbers. You find the result. Works every time. Logarithm of a power is a multiple of the logarithm of the base. So log of a to the b, just think about the brackets are there, right? Even though you don't write them. This is the same as b times log a. b log a, or as my students like to say, bloga. A little strange maybe, but whatever helps your memory. Works the same thing over here. I'm not sure how you'd pronounce this if you're trying to, but b times ln of a. Blina. b times ln of a. Sometimes people are just kind of, as a little way of remembering it, think, okay, well that can just go right out in front here. Multiply it like that, right? The power of what you're taking the logarithm of, if you can express it as a power, goes out in front like that. And the last one here is the change of base rule. At some point you learn that you can write, if you have a logarithm of any base there, log base a of b, which is what that says, right? Log base a of b. Log base a of b. Now you can write that as the quotient of two individual logarithms. This is going to be the same as log of b over log of a. That's the change of base rule. You could write it in any base you want. Probably you want to write it in base 10 because that's what you have on your calculator, but you could write it in any base you want. Log base c of b over log base c of a. Right? Now, since you can write it in any base, well, there's no difference that you could use natural logarithms to express this. So that's the same expression over at the left there, but you could just write it as ln b over ln a. All right? So those are just some of the logarithm laws that you will need to recall from your previous pre-calculus math courses and bring into what we do with derivatives here when working with logarithmic and exponential functions.